Remember to have a sheet of paper and a pencil with you. Take a few moments to go ahead and gather those materials, and you will be writing a few things down on every slide. Today we will be discussing the history of evolution and natural selection. We will be going through some of the important figures, and when we're done with this lesson, you should be able to be familiar with how evolutionary theory got its beginnings. Alright, so let's start with Charles Darwin, the most famous, or notorious maybe if you think of it that way, of the evolutionists, basically because it's his theory, although, as we'll discuss, maybe not so much. Okay, so in 1831, Charles Darwin is age 21, and before that, he actually had a difficult time deciding what the heck he wanted to do. He went from job to job, basically an apprenticeship. It works a little differently than it does today, and it's also the British system of things, but he had most recently been in seminary school studying to be in the church, and decided he didn't like that. He came home, and his dad says, all right, that's it, you're going to take over the family business. And so he's sort of like, well, I don't know if that's really what I want to do, but his dad's not giving him a choice. And then his friend comes along and tells him, hey, you have this great opportunity to serve on my ship as a naturalist, which he had shown an interest in biology and naturalism, basically. And all his job would be to find animals and tag them and send them back to Britain to be studied later. And he decides he really wants to do this, approaches his dad about it. His dad says no, no, no. So he's talking with his fiance's father, who just happened to be the brother of his father. So if you sort of work that one out, yeah, that's right, yes, they were related, and it was his fiance. Anyways, so he sort of is talking over everything with his uncle, and his uncle says, well, I'll talk to him and basically tell him, hey, if this doesn't work out, then you can take over in my business and marry my daughter, which he does eventually marry, by the way, and everything will be good. So, anyways, he talks, his dad finally gets talked into allowing him to go to South America and around the world, and he does, and he gets down to South America, and let me see how this works here. Alright, so if you look down in this area, see how he's traveling down here, and he goes up and down the coast of South America and up and around, and eventually gets to Galapagos. And this is sort of significant because he notices a bunch of animals there. He finds a bunch of fossils, sends some of those fossils home. Even at that, when he's in South America, he starts to think about things because he finds this really large animal that looks like a really big armadillo, and it's not even closely related to an armadillo. It's called a glyptodont, and actually, one time I was at a natural history museum, and some person in a wheelchair came, well, it was more one of those scooter things, comes up to it and goes, wow, that's a really big armadillo. And I had to bite my tongue because I knew it wasn't an armadillo, and it does look a lot like an armadillo, but it's not even closely related. So this even starts getting him thinking about, well, gee, how are these animals related? And so then by the time he makes it over here to Galapagos, over here, he notices there's a lot of animals that are very similar to the mainland of South America. For example, you find iguanas over here, but they live in trees. Over here, they live in the water. Well, they don't live in the water. They live on the rocks and then dive into the water and eat things off of the ground. You see cormorants all over here, and they dive into the water. You know, they fly around and dive into the water. But the ones in the Galapagos Islands, their wings are little stubby things, and they swim around more like penguins under the water. So again, it gets him thinking about some stuff, but doesn't really say too much about it. Starts to talk maybe a little bit with his friend who's the captain of the ship about this whole spiel about, you know, well, wow, how are these animals maybe related? Maybe it's not everything we thought it was. And you gotta understand that, alright, so Darwin's coming from a religious background. You know, he was in seminary school, and the current scientific thought is that God is perfect, and therefore all of creation is perfect and nothing would ever change. And he's starting to think, well, maybe some of these animals would change over the time in order to, better be adapted to their environment. Now, this is not heresy necessarily today. I mean, to him it's not, because he's thinking, well, if God's so perfect, these animals would be able to change and adapt to their surroundings. But current thought is, he's perfect, there's no change, no way. And so his friend basically tells him, shut up, don't talk about this, you will get hung up. And by hung, I mean strung up and hung in the city square, because this is all heresy and it's bad and you can't talk like this. Just don't talk about it. And so he really doesn't. He visits the Galapagos Islands in 1835, so this is 4 years into his trip off of South America. Returns to Great Britain with some great ideas, but he doesn't say anything for almost 30 years, for a long time. In this time, he does sort of kind of lose faith. He loses a bunch of children. Probably had something to do with the inbreeding. But lost a lot of children, and sort of loses his faith in God. He does become a biologist, does work at a distinguished university, does work on writing a book, but doesn't ever publish it. He just sort of sits on the whole thing and just, doesn't say too much. Okay, so the whole reason that Darwin ends up publishing his articles is because of a man named Alfred Russel Wallace. Alfred Russel Wallace was more or less a pest to Darwin, and he would write to him frequently, and Darwin's now an established biologist in a university, and so he had heard about Darwin and his theories and was writing back and forth to him, and Darwin basically just filed his letters in file 13. I mean, he read them, but just, whatever, this young kid and all this other stuff. And so Wallace is writing from Indonesia, and he's making some things that he's noticing. And so actually what happens is he gets really sick and makes some observations about Indonesia here. He notices that all the animals on this side of this line that's marked on the map were mammals that were similar to what you would see in Asia and Africa, apes, monkeys and such, whereas everything on this side would fill the same type of niches, because it's the same type of climate, same type of pressures, same type of environment, but these ones were all marsupials like you'd see in Australia. They were possums, not opossums, but possums, and like tree kangaroos and such. And so he writes to Darwin explaining basically natural selection, and Darwin's faced with a dilemma. Shoot, what do? Do I just throw this away and ignore that he's writing this article and hurry up and rush and publish my book and just sort of stab this guy in the back? Do I let him take all the credit? Or he comes up with a third option: let's co-present to the Linnaean Society, which is basically part of the Royal Society. It's like the biological division. And they did. They co-presented, and then he, a year later, published Origin of the Species. So it was sort of like a kickoff for his book. So had it not been for Wallace, we very likely would have never heard anything from Darwin, or had he not been writing and pestering Darwin incessantly, we maybe never would have heard of it would be called Wallace's theory of evolution. And so here you can see Darwin's little path around the Galapagos Islands, and they sort of zip around all over the place. An interesting thing to note here is that while they're bebopping around, they are killing turtles, actually tortoises, mercilessly, just walking up to them and cutting them up and flipping their shells over and using them for pots to cook them in and having turtle stew. They ended up bringing all these shells back, and when Darwin gets back to England, he realizes, hey, I could actually figure out which island I was visiting at the time and which meal we were eating based on the shape of the shells. They're different for different reasons, for different climates and such, because each of these islands have different factors affecting them. So, like, for example, this one's got more mountains over here, and then this one over here has some mountains, but also has some lower area. I think this one over here might have like a drier climate. So, there's some that are more desert-like, more woodland-like. Some of them are more rainforest-like. And they have different climates. And So yeah, if you go back to this point here, he could tell which island the tourist came from based on the shell shape, because like having a really big clumpy shell on an overgrown island with a lot of jungle would be a bad idea. Those were the ones that lived in like the swampier islands, and the ones that had more like flat grasslands. That's where you'd find the ones with the bigger shells. Um, all in the all the birds in the islands were finches. He sent all these birds back, and actually, an ornithologist, that's somebody who studies birds, was looking at these birds and said, "Hey, these guys shouldn't be related at all." Darwin called them things like finches and crows and sparrows and uh, even like woodpeckers and such, and thought they were completely unrelated. But it turned out that like something to do with their feet and their foot structure made them all finches, and so they were closely related, even though they shouldn't be. Um, this gets him thinking, well, maybe these birds were surviving and had adaptations on these islands to suit the environment of each island. These islands did have a much different climate than South America. As a matter of fact, you had many microclimates in there. The iguanas, I already mentioned earlier, they would dive down and eat the moss, or actually the algae off of the rocks. In the South America and Central America, they live in trees. And then he started looking at the fossil record. Remember, I mentioned the glyptodont, but there were other things he found. And there were a lot of other organisms that he looked at. I mentioned the cormorants. And so his ideas are, wow, something's causing these animals to change, something in the environment. So let's look at some of the major ideas from Darwin. Okay, so here you might recognize this picture from a Super Bowl a couple of years back. This is the Dober Wawa. And basically, we're going to start talking about what makes a species a species. One of the ideas is that a species is any organism that can breed with another organism and produce babies that then can breed with the rest of the population. So in other words, all dogs are considered the same species because they can produce offspring together. Even wolves, there's a little bit of a debate about that, but that's a different idea altogether. We'll talk about that at another time. But so here you have the Dober Wawa, and really this doesn't exist. This is just something that was done for a commercial. But other than for mechanical reasons, these dogs could breed. The sperm could fertilize the egg, and we could produce a Doberman Chihuahua mix. And that's why they consider it the same species, because then it could breed with any other dog. Whereas if you take like a horse and a donkey, you get a mule, it's sterile, and it can't interbreed with either species, and so therefore they're considered separate species. Okay, so artificial selection had been around for quite some time. They understood what this meant, and this was basically selecting for specific traits. So, for example, you have your Chihuahua, which is bred to be a small little lap dog that fits in your purse and you can carry it around and looks cute. I haven't figured out what else Chihuahuas are good at. Dachshunds. See, we should be the cardinal dachshunds, not the huskies, because dachshund comes from German and it means badger hound. The dachs is a badger. Greyhounds. Greyhounds are bred to be long and sleek and run really fast. Mastiffs are these big dopey dogs that children can bounce on and tug on, and they just sort of lay around. But when they bark, they have a ferocious bark that sounds very scary, and they're very big dogs, and so they're great guard dogs, especially for people with children. We've artificially selected vegetables. We've artificially selected all of our livestock. We knew that we could select for specific traits. You breed a fat sheep with a fat sheep and you get fat sheep. This is good for the market and good for food. Okay, so artificial selection. Darwin's thinking, well, maybe something is happening in the environment. Man can breed animals and make them look different, so something must be going on to cause all of these animals to be similar in a natural way. In other words, natural selection. First thing he mentions is struggle for existence. All species within a population are in competition for the same resources, food and habitat. In other words, these animals are fighting to live. They want to survive. Imagine a whole bunch of people being locked in a room with no food, or maybe very little food, for maybe a year. What's going to happen? Well, there are different traits that are found in different people, and some of those traits will help them to survive. Kind of think like Hunger Games here. Different people from different colonies had different abilities that made them more likely to win the Hunger Games. So it's sort of kind of the same idea there, is that this happens in the real world. Not all bunnies grow up to be adult bunnies and have bunny families. Many of them become food for other things. So there is a struggle to survive, struggle to find food, struggle to not get eaten yourself. And there's variation. Species will show different traits that may or may not benefit an organism's struggle to survive. In other words, there's variety. The person sitting next to you or in the next room over is very different than you. Even though there's a lot of traits you may have that are the same, there's a lot of them that are different. No matter how closely related you are to them, there's a lot of difference. Unless maybe you're identical twins, in which case, yeah, there's not so much variation there. And then this last term right here, heritability. This one sort of had Darwin stuck. If you remember previous in the class, I mentioned that Gregor Mendel, his work was sort of lost. If Darwin just could have figured out how the heck these traits passed on from one generation to the next. But regardless, he said there was some heritability or some way to inherit traits and pass them on. Here's some things down here where Darwin was starting to notice. Alright, so you notice here it's very difficult to pick out this moth. And this moth is very easy to pick out. And if you lived in London where it was filthy because it was the Industrial Revolution, this moth was very, very easy to notice, and this moth was very difficult to notice. And that is because the Industrial Revolution burnt all kinds of coal, and so soot would land, and so these moths right here had a better chance of surviving than these ones. These were called peppered moths, and they actually were the same species. They just came in two varieties. You go out to the countryside, away from the city, though, and now look, you can't hardly find this one, and this one's very easy to find. So what does finding moths have to do with evolution? Well, in the city, you see almost exclusively black moths, and in the country, you see almost exclusively these white with little black streaks. And that's because in the city it's dirty, and the birds they'll pick this one out right away, and he's gone in a matter of seconds. And in the country, this one is gone in a matter of seconds because he is easily seen. So the moths at this point sort of start to support Darwin's theory here. What they're saying is, or what Darwin was saying is, these organisms have variation, and depending on the environment, their chances of survival are greater or less, depending on which variations they express. Okay, so another idea from Darwin was overproduction of offspring. Basically, there's reproductive advantages, and organisms will produce way more offspring than can survive, and the ones that survive have a reproductive advantage. In other words, they're alive and can reproduce and not dead and then some other organism's belly. Alright, so if you remember this chart from earlier in the year, look at the bunny populations. They go up, yay! Well, when the bunny populations go up, so don't the lynx populations. They go up because there's plenty of food for them to eat. Now the bunny population crashes. Now goes down the lynx population shortly after. Less predators. Now the bunny population goes up. Yay! Now the lynx population goes up. And so what's happening here is that each of these rounds, a lot of the bunnies are dying, but the ones that survive are passing on the best traits for that environment, giving them the best chance to survive, and then reproduce, because dead bunnies don't reproduce. They're dead. Okay, so another theory that Darwin comes across, or I guess postulate that he sort of discusses, is overproduction versus nurturing. There's a lot of debate about this even today. Alright, so if you look at some organisms low on the food chain, what do you think happens to the numbers of those organisms. Think about organisms that are low on the food chain, like termites. All right, now, what is their strategy? Well, overproduction. They're going to produce a heck of a lot of little babies, and hopefully some of them make it to adulthood. They probably aren't going to spend a lot of time caring for them, although termites will take care of them. But think of sea turtles. Sea turtles get up onto the beach, lay some eggs, and they wander off, and, well, kids, hope you make it. And most of them hatch, and most of them make it to the ocean. No, not most of them make it to the ocean. Most of them are dead before they even get to the ocean. Only a small chunk of them actually even make it to the ocean. And that small chunk that make it to the ocean, almost all of them die, if not all of them. The turtle will lay hundreds of thousands of eggs over its lifetime, and maybe 2 or 3 make it to adulthood. Oh, that's very sad. But you look at things like, well, humans, and we have 2 or 3, or, well, some populations 10 or 11. But most of the time, you have 2 or 3 children, and most of them make it to adulthood because we take care of them. Even if you look at like birds, they take a lot of care of their offspring, and that's the nurturing. They don't have hundreds of thousands. They have a couple, and guess what? 2 or 3 make it to adulthood, maybe sometimes 4 or 5. And that goes back to this overproduction of offspring. There's way more offspring than could possibly survive. Most of them end up being food, but the ones that do survive, reproductive advantage, and they have the best traits. Natural selection, because there's a very good reason why you should be eliminated from the gene pool. This is not a smart man. Well, actually, he probably is, but I don't know. I just think that it's not a good idea to go up to lions and kiss them on the nose, because you could sooner or later end up being lion bait. Okay, anyways. So, natural selection, survival of the fittest. It does not have to be strongest. Sometimes the fittest could be the smartest, like staying away from lions. But anyway, yeah, natural selection is survival of the fittest. Sometimes it's blending in the best, or being the smartest, or being the fastest, or sometimes it's even being the slowest. There can be advantages to being slow. So organisms of a population with certain variations will be favored to survive and pass on their traits due to the environmental pressures, because they have that reproductive advantage. Okay, so what we have going on here is we have speciation, which is a thought by Darwin, and so we have this butterfly, which arrives from the mainland, and it can survive fine on this island here because there's lots of tall trees, and it can hide this large butterfly pretty easily. And another storm comes along sometime later and blows the butterfly over to this island, and there's what we're going to call reproductive isolation. In other words, these butterflies will not fly back to this island because it's too far away, and they'll find mates just fine right here and mates just fine right there. And on over here where we have trees and such, the butterfly can feel free to get larger and larger and larger and still hide pretty well. But over here there's no large trees, and so only the smaller butterflies survive, and you end up with a smaller and smaller butterfly because there's no place for them to hide. And even over time, what's going to happen is B and C now are going to be 2 different species, because even when it gets blown back across over here to this mainland, now the 2 species of butterflies can't reproduce with each other, and now they're different species. And you can even see C even finds its way over to here. C can survive here in the forest because even though it's not as big as the other one, it still can survive. It still can hide just as well. Okay, now that's speciation. Now, if you continue on with this step 4 of the chart, basically what's happening is we're ending up with another species. And so when you have one species become 2 different species, that's speciation. When you have one species becoming multiple different ones, filling multiple different niches, that's when we have adaptive radiation. There's a slight difference there, and we will talk about that later at a later date. Okay, you have allopatric speciation, and then sympatric speciation. Allopatric's the easier one to understand. That's what we just looked at on the last page with the butterflies. But what happens here is we have happy mice, and we have a river, and the river changes course for some reason. Who the heck knows why? But these mice can't swim, and these mice can't swim, and so they can't get together and be happy. And so after a couple generations, they become more and more different. And even when the river changes back course, now they're so different they can't interbreed because now they're two different species. But there was a barrier separating them, keeping them from breeding. Now, this can also happen without a barrier, sympatric. By the way, patrick means of country, so it's the same root word of patriot. So sympatric means together at the same country. So right here we have this forest, and white mice are going to stick out in the forest, and so the darker ones tend to survive. And even though these dark mice can come over here and totally mate with these white mice, they can't actually, because once they start hopping out here, the owlet's sitting in a tree or the hawk comes down and eats it, and so they don't reproduce. And so even though there's nothing physically separating these mice from getting together, well, there's something that's keeping them from getting together, and that's the predators. They're hanging out there, and these brown mice just stick out so much out there. And so over time, these mice become very different than these mice, and that is reproductive isolation. And it is sympatric because even though there's not a physical barrier, they couldn't interbreed and they become too different. Okay, what I'm going to be looking for from this set of notes is that you wrote down a couple of the things I discussed, made a couple of side notes. I didn't ask many questions to leave you places to add additional proof that you viewed this, but in order to prove that you have viewed this, I want you to copy down the notes and then show me a couple things that I maybe mentioned in the slides that weren't specifically stated in the slideshow. Thank you, and have a nice